Today, let's look at the world around us a little differently. We're going to see how a ton of everyday objects are actually just geometric puzzles waiting for us to solve them. We're diving into the surface area of combined solids.
I mean, have you ever really stopped to think about an oil tanker, a rocket, or even something as simple as an ice cream cone? They aren't just one single shape, right? They're actually combinations of different geometric solids. These things might look pretty complex at first glance, but they're really just puzzles. Think about it. An ice cream cone is just a cone with a hemisphere sitting on top. And that oil tanker, it's a cylinder with a hemisphere capping each end. Once you start seeing the individual pieces, the whole puzzle gets a lot easier to solve.
So what's the official term for this? Well, in geometry, we call them combinations of solids. It's really any object you can make by joining two or more basic shapes that you already know, like cylinders, cones, and hemispheres.
Let's break down that oil tanker. It might look like one big, unique shape, but it's really three simple parts. You've got a hemisphere, a cylinder in the middle, and another hemisphere on the other end. Seeing the simple shapes inside the complex one is really the first big step to mastering these kinds of problems.
Okay, this brings us to the golden rule, the one thing you absolutely have to remember for combined solids. When you join two solids together, the surfaces where they connect, they just disappear. They're not on the outside of the object anymore, so they are not included in the total surface area. And you know what? This rule actually makes our lives way easier. It means the total surface area of the new object is simply the sum of the curved surface areas of the parts you can see. You're only adding up the bits that form the new exterior. Simple as that.
All right, enough theory. Let's put this into practice and see how it works. We'll start with a classic example, a simple toy top. So here's what we've got. Our toy top is a cone sitting right on top of a hemisphere. The total height is 5 centimeters, and its diameter is 3.5 centimeters. Our mission is to find the total surface area. So remembering our golden rule, we're not going to count the circle where the cone and hemisphere meet. That means the total surface area is just the curved surface area of the hemisphere plus the curved surface area of the cone. Okay, here's our game plan. First up, we'll figure out the curved surface area of the hemisphere. Easy enough. Then, we need to find the cone's dimensions. We'll get its height, and from there, we'll calculate its slant height, L, which is absolutely crucial for finding the cone's surface area. Once we have the curved surface area for both parts, we just add them together, and that's our final answer.
And after running all the numbers, the total surface area of the toy comes out to about 39.6 square centimeters. See? When you break it down into simple steps, even a shape that looks tricky becomes a totally manageable problem.
Okay, that was a great warm-up. Now, let's step it up a notch and tackle a more complex problem, the kind you'll very likely see in your board exams. We've got a rocket that needs to be painted in two different colors. So, this toy rocket is a cone on top of a cylinder. The cone section needs to be painted orange, and the cylindrical part needs to be painted yellow. Our job is to find the area for each color. Now, for the orange area, we have to be a little careful. It's not just the curved surface of the cone. It's also that little ring at the base where it meets the cylinder. For the yellow area, it's a bit more straightforward, just the curved surface of the cylinder plus the area of its circular bottom. So the area that needs to be painted orange comes out to about 63.6 square centimeters. And the area for the yellow paint, well, that's much larger, at about 195.5 square centimeters. Breaking the problem down by color was definitely the key to getting this one right. Now that we've worked through a couple of examples, we can actually pull out a really simple and powerful strategy. This is something you can apply to any combination of solids problem you face, especially in an exam. Let's just call it the deconstruction method. Step 1. Identify the individual shapes. Is it a cone on a cylinder? A cylinder with two hemispheres? Step 2, and this is the most critical part. Figure out which surfaces are hidden where they're joined together. Do not count those. Step 3, write down the formulas for the visible parts only, which almost always means you'll be using the curved surface area formulas. And finally, step 4, just add those areas up to get your total. Now, to make sure you nail these questions and get every possible mark, let's go over the most common mistakes students make. Because let's be real, knowing what not to do is just as important as knowing what to do. The biggest mistake, the one that costs the most marks by far, is including the area of those hidden surfaces. Always, always remember the golden rule. Other common slip-ups include using the wrong formula, like a total surface area formula when you just need the curved part, or simple calculation errors, especially when you're rushing to find the slant height. So always take a breath and double-check your work. So, what should you really practice for your exam? You're definitely going to see these classic problems pop up. A toy, just like the one we solved, a medicine capsule, an oil tanker, or a tent. Seriously, if you can master these types of questions, you'll be ready for pretty much whatever they throw at you.